Hello, ninth graders. We are starting our very last lesson of this unit. And from teaching this last year, I do have a word of warning is that a lot of students found this last unit last year to be very difficult. So this is our last lesson leading up to the unit test. So just be aware that you can always re-watch this video. You can go back and watch it as many times as you need in order to be able to understand what's going on. You also have a multitude of practice out there on the internet for you to go find. We've also provided you some. So you're not alone in feeling maybe by the end of this unit that this might be a little confusing. I'm going to try my best to make it less confusing, but if you're still finding that you're at a little bit of a loss, that's okay. You have lots of resources to try and help yourself feel found. All right, so we have something called an equality of surds. And what is a surd? That is a great question. A surd is a non-perfect radical. So an example would be like the square root of 2 or the cube root of 5. It doesn't have to be a square root, right? If it's any radical that is not considered a perfect of that radical. And what we want to talk about with equality of surds is this definition. And the definition says for an irrational number, which we are going to label as the square root of k. For something to be irrational, that means that it cannot be represented as a fraction. And so this means that this is a number that has non-repeating decimals, there's no pattern to the decimals, and it goes on forever, right? So this is what an irrational number is, so the square root of 2, right? So for an irrational number, square root of k, and rational numbers, and we're going to just label them with variables. So we're saying, hey, all of these variables have to represent this is an irrational number, and these have to be rational ones. So like fractions or whole numbers. We've got this rule that says a plus b times the square root of k equals c plus d times the square root of k if and only if, remember that there's this shorthand that we have in mathematics, and this is one of those shorthands, IFF, if and only if. It means it's a two-way road. It means that, if I finish this sentence, if and only if A equals C and B equals D. So if and only if this guy equals this guy and this guy equals that guy. So it's a two-way road, which means that if I know this, then this is true. Or if I know this, then this is true. That's what an if and only if statement means, that you can start from either end of the sentence and go to the other end of it. And it's a logical statement that still is true both ways. Okay, so it's pretty straightforward. It means that like x plus y square root of 2 equals 2 plus 4 square root of 2. It means that your x is equal to 2 and your y is equal to 4. That's all it means, that if you have it set up in a system that looks exactly like from one side to the next, exactly the same, that the spots that are like terms that are in the same spots are going to be equal. They have to be equal in order for this statement to be true. Now, it's going to get more difficult than that, of course, because we're in accelerated mathematics, but that's the general idea. And as long as you can keep that in mind, I think a lot of things will start to look simpler. Okay, so 1A is like your very basic application of this. It's already been simplified down. You've already got spots that are in similar places. And so from right now, you don't have to do any mathematics. I just want you to tell me what is x and what is y. Notice here that x is in the same place as 2, so x equals 2. And then y is in the same place as, be careful, it's minus 6 here, which means that your y is negative 6. So this is the general idea of what we want to get to. We typically start with something a little bit more complicated, but this is what we want to get to so we can then answer the question. Okay, so we're going to do 2 together. Two, there's more than one way we can go about this. And for right now, I would like for you to think and look at this. The idea is that we want to get this piece by itself on one side of the equation. So what do you think your first step here would be? There are two things that I would have accepted as answers. One of them is that you could FOIL here. You could absolutely FOIL out 2 times x, 2 times y, square root of 2, negative 3 root 2 times x, negative 3 root 2 times y root 2. FOIL it all out, combine like terms. That is absolutely an okay first step. It's not the best first step. It would end up being a lot more work for you, but I'm all about like go down the path that makes sense for your brain that you connect with, even if it's longer, even if it's harder. It might just be easier for you because it's how your brain is working with this problem and it's how your brain is making sense of the problem. So you could have done that. Would have taken you longer. Or you can just divide out this guy, right? If these two pieces are being multiplied together, and really the main idea is that we want to get something that looks like this alone on one side of the equation. What if I just divide this out on both sides? And that is probably your easiest way to go about a problem that looks like this. The reason why, be very careful here, because notice that there's a difference between B and C. The reason why I would do that is because all of my variables are here, right? So by dividing out, I'm essentially dividing out a really funky looking number to both sides and isolating the variables on this side. Whereas on C, if I did the same thing with this guy and divided this out, yes, this is all numbers, but over here I've got a variable. And what I've done is just further complicated the things that are going on around this variable by dividing out on both sides. So just be very careful that in this instance, I would absolutely divide both sides by this whole thing because there's no variables in here and no variables in here. But for this one, when the variables are all intermingled, I would not do it the similar first step. Okay, so I get x plus y square root of 2 by taking this guy and dividing it on both sides. I end up getting the square root of 2 divided by 2 minus 3 square root of 2. We really want to get, because we've got now this thing alone on one side, like we do in our previous problem, but we don't have now this a plus b square root of 2 situation over here where we can start combining like things. We've now got a fraction. And we really don't like that fraction being there because it's complicating things. And so how would we isolate or not isolate, how would we simplify this fraction? How would we get rid of this fraction? And this is why we learned this in previous lessons, is that we already know how to get radical rational expressions out of being a rational expression. Radical because there's roots here, rational because it's in a fraction. So we're trying to get it out of a fraction by multiplying by its conjugate. And we know that's going to make this denominator go down and simplify down to a non-rational expression or number. All right, I'm going to distribute that square root of 2 to everything in the numerator. Notice that I put it in parentheses to remind myself that it doesn't just get multiplied to one thing, it gets multiplied to both things. So I get 2 square root of 2 plus, and then that's 3, and then root 2 times root 2 is just 2 in the numerator. In the denominator, I know it's going to be the square of the first term minus the square of the second term. So that's going to be 3 squared as well as the square root of 2 squared. This all simplifies down to 6 plus 2 square root of 2 divided by 4 minus 18 is going to be negative 16. And remember that then this can simplify down to be 2 fractions separated out. You just have to bring that denominator with both of those numerator pieces. So it's going to be 6 over negative 16 plus 2 square root of 2 over negative 16. So then that simplifies down to negative 3, oh wait, no, not 16. 4 minus 18 is negative 14, my bad. Because that's going to be negative 3 over 7, and then minus, and that's going to become 1 over 7. But remember that the 2 does not simplify down because the 2 is inside the square root, whereas the 14 is not. So it only can be minus 1 over 7, square root of 2. Okay, so now we've gotten it down to a form where we can start matching up what the like terms are. So this is where it gets complicated, is the fact that in order to isolate it and get it into this idea of the equality of surds, you need to do some sort of manipulation. And it's all manipulations that you've learned how to do in the past. Whatever you do to one side, you have to do the other. You need to subtract from both sides or add from both sides, divide, multiply to both sides. How to multiply by the conjugate, right? These are all manipulations that you know how to do. Now you're just trying to figure out when do I use which manipulation in order to get it into the form that I want. So remember that you want it in this a plus b square root of k form. So how do you then manipulate what's going on in order to get it into that form? That is the puzzle here. Okay, because now it's just, we can see, x equals negative 3 over 7. And y equals negative 1 over 7. And that is your final answer. So if you had FOILed up here and then tried to simplify and combine like terms and all of that, get your variables on one side and your numbers on the other, you would have gotten the same answer, right? So there's more than one way to approach this problem, and they all lead to the same answer as long as everything's been done correctly. I just tried to show you what the easiest solution to this process was.